Okay, let's look at the homework 2, problem number 3. Right. So we're going to use a common Maclaurin series to find the Maclaurin series for arctangent, which can be written as the antiderivative of 1 over x plus u squared. Right. So let's do that. Alright, first I'm going to call the arctangent f of x. So we're looking for the Maclaurin series for this function f of x, right? Then we take the derivative of f of x first because we don't know what to do directly from here. But if you look at the derivative, f prime of x, right? And we can use the fundamental theorem of calculus. Derivative of this guy is simply 1 over 1 plus x squared, right? Because you're taking the antiderivative and then derivative, so it really doesn't do anything to the inside, so you just get that. All right, and which can be written as this: 1 over 1 minus quantity negative x squared, right? And remember that we have this Maclaurin series summation, and goes from 0 to infinity, right, of x to the n, right? So this is think of it as a geometric series. So this is going to be simply 1 over 1 minus x, right? So we can mimic this. Only difference between this guy and that guy is this guy has negative x squared where x is, right? So we can rewrite this guy as a summation. Maybe I'm gonna go down here, right? So we can use the summation, right? N goes from 0 to infinity, right? Then we're going to rewrite x, replace x by negative x squared. So you have negative x squared and raise it to the n, right? And we can clean this up a little bit. So we're going to make it look like a alternating series by pulling out negative 1 to the n. So you have a negative 1 to the n. Right, then you have x squared to the n is x to the 2n power. Right, so we have a Maclaurin series for the derivative of the function we're interested in. So we can take the antiderivative to get the Maclaurin series for the original function. So f of x is equal to, right? So we take the antiderivative of this guy, so it's going to be a summation. N goes from 0 to infinity. Then you have a negative 1 to the n. Then you have x to the 2n with respect to x. Alright. Then the good thing about the power series is that you can do derivative or antiderivative term by term. So we get to kick the summation sign outside of the integral. So summation, we can do that later, right? Also, negative 1 to the n has nothing to do with x, so that's a constant. So it's a negative 1 to the n, right? Then all you really have to do is integrate x to the 2n with respect to x, right? But this is just a power rule, so we can easily do that. So it's going to be a summation. N goes from 0 to infinity. Right? You have a negative 1 to the n. I'm just copying those. Right? So antiderivative of x to the 2n would be a power rule. X, add 1 to the power, so 2n plus 1 over, and divide by that power. So it's a 2n plus 1, right? Then since this is an indefinite integral, you might have a constant, so I'm going to say plus some constant c, right? we can find c by doing this. We know that here f of 0 is supposed to be, right, so plug in 0 for x, it's going to be 0, right, x here is 0, and you have a du over 1 plus u squared, right? But if the integral goes from 0 to 0, the integral is 0, right? So we can use this fact or you can say arctangent of 0 is 0, same thing, right? We can just use this fact and here plug in, right? So since n starts from 0, so you're going to have a smallest power would be x to the first power. So every single term in this series is going to have x in it. So we are plugging in x equals 0. So all these terms is going to be 0. So what's left is just going to be c. But f of 0, we just said that it has to be 0. So therefore c is actually 0. Right? So therefore we have expression for f of x, or arctangent. So arctangent of x, it has a Maclaurin series summation, and goes from 0 to infinity. Then you have a negative 1 to the nth power. Then you have x to the 2n plus 1 over 2n plus 1. Right? So this is the Maclaurin series for arctangent of x. Right? That's it. I hope that this was clear.